Very good afternoon, everyone. Welcome to my last session of Tech Days this year, where I finally will be able to reveal the stuff I've been working on for the last year and a half, bringing reactive extensions to the cloud. Now, I won't just talk about the stuff I've done over the last, 1 year and a half. That will be sort of the last part of this talk to sort of whet your appetite for what will be coming. In fact, there will be a Channel 9 talk likely next week about some of the future stuff we are doing. But I'd like to get started by explaining how reactive extensions can be used in a whole bunch of scenarios to actually solve a lot of event processing problems. So let's get started by doing an on-next call. For those of you who are already familiar with RX, that's a little pun on the observer grammar, and talk a little bit, first of all, about the theory behind RX. Now, how many of you have actually used reactive extensions already? Okay. The number is growing every year, but still, I have sort of the urge to talk a little bit about the theory as well, so that we are all at the same level and sort of understand what the abstractions look like. Now, before we go there, let's first motivate why we're doing something like reactive programming. And it all boils down to doing large-scale or small-scale event processing. And you may say, well, event processing, is that hard? Well, the answer is, you have a whole bunch of different things that provide events all over the place all of the time, including things like stock tickers, RSS feeds, those are web feeds obviously, but also all of those sensors. And that's where we're sort of touching to this new thing of Internet of Things, where you have a whole bunch of appliances that are all sending information and beaming things into the cloud, and you have more information than you can process. So you need some way to actually tame all of those different streams of data in a way that's kind of uniform. And that's what RX really gives us, is like an abstraction that scales very well from the very small, such as like sensors on your phone, to the very large, like, for example, data feeds in the cloud that get weather information from various sensors in the field and sort of calculate what the weather is in a certain city, for example. And that last one is actually quite realistic, because for the work I've been doing over the last couple of years, we're dealing with large-scale data processing feeds in the cloud in Bing. And that's where, finally, I can tell that for the last year and a half, I've been working on this donut-shaped action figure called Cortana, which is the personal assistant that's coming to Windows Phone. And that enables you to do a whole bunch of interesting things, like remind me to buy milk when I'm near a grocery, for example. Well, the way we do near a grocery is, of course, by using RX rules on the phone, in fact, implemented using native RX, that listen to a variety of sensors. For example, we have observables, which we'll talk about in just a moment, that can notify us when we break a certain geofence. So when we're in the proximity of a particular location, we'll get a notification and we can process that event by, for example, bringing up reminders on the screen. Of course, that's a very simple kind of query. We have much more complex ones that deal with data in the cloud as well, and things that actually stretch both the device and the cloud. A good example is the time to leave reminders that we have in Cortana, where we can actually tell you that you have to leave early for your next appointment, because we know where you are, like your device has a sensor built into it. We have your shadow calendar in the cloud, completely isolated from other people, of course, where we know where your next appointment is, so we can compute using the traffic feed, the live stream that actually exists in the cloud, when you have to leave to make your appointment. That's an RX query that's running both on the client, in the cloud, and is connected all the way up using the cloud and your data connection. So a whole bunch of things we can do there, both using, on the one hand, native code with RX++ on the device, with a very small footprint. We're running all of the time. We're resident in memory. And I can tell you, the Windows Phone people want to squeeze out every kilobyte of memory that they can squeeze out, because like battery life, the number of applications you can run, making sure this thing can actually run on very low-end hardware is a very important thing to keep footprint low. So there we went for an RX++ implementation. And in the cloud, well, we're using RX.NET, but actually an extension on top of that that allows us to scale across, in fact, a variety of data centers around the world. So as you can see, that's all scales. That's what I mean with all scales, all the way from small devices all the way up to the cloud, where we're processing millions of events on a daily basis. And of course, that number will grow all the time. So let's talk about the architecture of RX so that we understand the basic principles and then see how we can map those on both very small scale programming as well as large scale cloud programming. Generally, there are three things in RX. We have the bottom layer, where over the last couple of years I've always sort of been dancing around this, cattle on stage here, saying like, in the middle we have cloud there, we can do things at cloud scale using our scheduler abstraction as well. And most people didn't care because they talk about like, well, I can do things on the thread pool and parallelize things locally. But as we've just seen a moment ago, we can have concurrency that scales all the way to the cloud. In the middle, we have the abstractions. That's the first thing I will want to talk about, the event stream representations with observables and observers. And then on top of that, we have a query language. And you can sort of think about this like the way you think about a relational database, where you have a storage engine at the bottom with a SQL operating system that does a whole bunch of threading and concurrency. And on top of that, you have a relational engine that gives you a query language. Of course, most of your time will be spent in the query language and at the level of the event streams, as opposed to dealing with those low-level concurrency primitives. We'll talk about all three of them because all of them have a very neat use case. So let's start by talking about the way we represent streams of events in the world of reactive. So very briefly, it's a very simple pattern that you can actually find in the Gang of Four design patterns book, called the observer pattern. It's just a little bit different because the observer pattern is not the most pure one, according to a variety of interpretations. But what we have is an observable sequence, which is your data source. And you can walk up to a data source and say, I want to subscribe to you. And the thing you have to give us is the way we can call you back. So it's just like a .NET event, really. .NET event is something that has the potential to tell you about stuff. The word potential is really a central thing here. But in order to make things kinetic, now I'm getting into a physics interpretation here, you have to subscribe. Otherwise, nothing happens, really. So turn your potential into kinetics, and the kinetics in this case is pushing events to your observer, where you can see, oh, something is happening, something is coming out here. Other analogy would be an apple that that's hanging on a tree, and if you shake it, the potential energy becomes an on next of an apple landing on your head, right? So that's pretty much the same thing. So how does that now play out in terms of being more useful than, for example, .NET events? Like, yeah, .NET events seem quite reasonable to do this kind of stuff. You just hook up an event handler and you get your events. Well, the thing is that we wanted to have a first-class representation of events as opposed to a metadata representation that you have in the .NET framework. Like an event is just, as you know, likely, a combination of an add and remove handler method that just gets a piece of metadata on top, and that's what causes it to look like a lightning bolt in Visual Studio, the fact there is some metadata. But other than that, you can't really grab an event and say, this is a great event, let me give that to some library to do something with the event. You can't pass those guys around. So the fact that you can't pass them into a subroutine and you can't return them from a subroutine makes them not very compositional. So .NET events are not the best abstraction to do this kind of stuff. In addition, because you can't really represent them as objects, you can't mock those objects by sort of creating fake implementations for them. You would have to mock the container of the .NET event by implementing your iForm or iControl with custom events inside of it. You can't just mock, for example, the click event of a button by providing a different implementation. So that leads to the creation of a bunch of interfaces, well actually a bunch of two in this case, called iObservable and iObserver. And as you can see, it follows exactly what I had on the slide a moment ago. You subscribe to an observable given an observer. And an observer is just an interface implementing three methods. A method called onNext, one called onError, and one called onCompleted. From that, you can already see that sequences can terminate, which is quite essential to be able to do certain kinds of composition. For example, you may be listening to a particular stream of data that at some point says, I don't have any more data. You have to switch over to a different stream to get more data. So you can do things like concatenating two event streams that are finite to create a new event stream. So We call those things error and completed punctuations in the stream, but let's ignore that detail here. Now, one thing that's very important to point out is, unlike .NET events, and we'll take a look at the contrast between the two in just a moment, unlike .NET events, there is no unsubscribe. The unsubscribe is governed by the disposable that gets returned from the subscribe. So you subscribe, you get a disposable back, and later you can call dispose on that thing to get rid of the subscription, to get rid of the whole event processing query that has been set up. Now, of course, on this micro scale, that doesn't look like very important. But as soon as we start adding query operators, this disposable is the one that saves the day. Because like unhooking all sorts of handlers everywhere, that becomes a state nightmare if we don't have some better way of doing that. So that's why we have iDisposable there. So why do we have 3 callbacks? Let's start with that. I already sort of alluded at it, that on-error and uncompleted are so-called punctuations, like the commas and the dots in your sentences. We have these because, well, there is something real about the world around us, right? Like, an event, okay, if it's local, it's rosy and shiny. Your event will always fire just fine. But as soon as you start doing things, at cloud scale, for example, well, things can fail. And somebody needs to tell you, well, I can't send you more events because this thing happened. Maybe you get like your authentication token expired exception. And we need to send that to your observer so it can react to it, for example, to renew the token and resubscribe. So there's a whole bunch of things that actually require us to add things like on-error and uncompleted. Now, what do valid sequences look like? You can have a whole bunch of on-next calls. We call this a marble diagram, named after the marbles that represent on-next calls containing a certain payload. So this is an event stream that at a certain time produces the value 0, different time a value 1, and later a value 2, and it keeps going. This could be infinite, I don't know. Maybe it terminates all the way, in the center of Den Haag, or I don't know which direction that points, but like it may be finishing someplace. But the important thing is that that spatial dimension here on my slide is really the temporal dimension, of course. Like you see the arrow of time passing by here. Here's a second arrow of time for another sequence that actually finishes. It just produces value 0 at some point, value 1 at some other point, and then at some point it says uncompleted. We can also have on-error, of course, like this. But we can't have this kind of thing. We can't have a sequence that, for example, has multiple callbacks happening at the same time. This is not a parallel world. It's not about delivering parallel events at the same time. It's about a sequence where you don't want to hear that, what's a good example here? That somebody died before you had the message that he was born, for example. Like, you don't want that kind of thing to happen. So you don't want out of order, you don't want concurrency where things can be ambiguous. At the same time, you get 2 events that sort of like need to have some causal order. So you can't have overlap of events or overlapping of events, nor can you have out of order arrival, for example, of an on-next message after a punctuation that says the stream has failed or the stream has completed. You don't expect that thing to happen, of course. So let's now talk about RX.NET. Later I will talk about RX JavaScript, and then I will talk about the stuff we're doing in the cloud just as a little appetizer for what's following in the next couple of weeks on Channel 9, and hopefully at some point, in public hands as well, because our main goal right now is to power Cortana, but we're really thinking about how we can spread the love for those new cloud scale technologies with RX as well. So here, let's talk first about why .NET events don't quite fit the deal for building large-scale event processing systems. Well, as I already alluded at just a moment ago, events are not first class. You can't capture them as objects, so you can't pass them around. And that really causes a lot of grief. Like, if you have your UI developers that build, the stock tick visualization thing, and you have somebody else who is very interested in networking and low latencies and is responsible to maintain the connection to the stock exchange, like those 2 people can't talk in terms of an interface. The UI guy says, please give me just your event source. But how are you giving an event source to a component? There is no object that you can pass into the constructor. Like, you need to do all sorts of wiring up from the UI to the library and register event handlers and stuff. Like, it's not super compositional. Secondly, those things tend to be hidden sources of events. In fact, like in this case, well, likely the args, for all I know, may contain some data. So you start dotting into the arguments and you're sort of on a treasure hunt for Easter eggs, like, where do you find, this little thing sitting under the tree, which is really the information. And sometimes you're looking and you don't find anything. Like the text changed event on Windows Forms doesn't contain the text that has changed. It just says something happened, like figure it out what happened, right? So sometimes those are hidden data sources. Now, an implication of not being able to pass those guys around is that you can't create a library that abstracts over common patterns. Like this pattern of simply subscribing to a stock tick event and then filtering it out, well, that's something you could abstract quite well. Everyone who's into LINQ will see that looks like a where operator, right? You give it a predicate to say, like, give me only those things that have an MSFT, but you can't write that because you can't write a method that takes in an event and produces another event. And finally, you have all sorts of nightmares around like resource maintenance, because to unsubscribe from an event, you need to know what you passed into it to begin with. And if you use anonymous methods and lambdas and those kind of things, well, you can't just copy-paste the entire code there to say, I want to get rid of this guy. Like, you need to store that anonymous delegate, that anonymous function, inside, a named variable, and then you can use that one to unsubscribe. So your code doesn't get super nice out of that. Now, with observable sequences, we can do, of course, quite better. First of all, because things are represented as objects, like iObservable of t, we can pass those guys around. So you can build libraries, you can have your constructor to your UI take in the source of the data that you want to subscribe to, which also means somebody can mock that very easily. They can just implement a different observable that just has a test sequence as input, for example, and everything keeps working. Clearly, now we know that it's a cup of tea. We see that the cup contains tea, so it's no longer a hidden data source, right? Like, you can clearly see it's an iObservable of something. No treasure hunt needed to find out what it's carrying in some event tags or something. Because we can pass those objects around, we can build libraries. Like, we can build things like a where class or a select or whatever. And finally, the way to unsubscribe is easier because you don't have to remember what you gave in the subscribe call. You don't have to remember your quote goes to something delegate that will handle the events that come out of that particular sequence. All you remember is actually the subscription disposable that will take care of getting rid of all of the logic that's sitting there. And now you can see that as soon as you start composing, that disposable is really the one that saves the day. Because if you have stockquotes.where, when you subscribe to that thing, you're subscribing to the where class, and the where class will, on its turn, subscribe to stockquotes. Like, you don't want to know that one is listening to the other and so forth. You want to have one single thing you can go to take that whole tree of operations away. And of course, if there's just a single source, you may say, well, that's not a big deal. But like, if you have things like, oh, you have stock quotes and you want to time them out based on a timer, compose those two streams and so on, if you do that in imperative code, you have, well, an event handler for a timer here, an event handler for a stock ticker there, and so forth. And then when you dispose that thing, well, you need to start unhooking all of those event handlers. In our world, you just have one disposable that you can actually walk to. Does that mean that .NET events are obsolete? Absolutely not. And let me show you a little picture here. I'll have a lot of those pictures today of some super symmetric interpretation of the world. We have methods, and what can we do with methods? We can write code. The void foo method has nothing in it, doesn't matter. That's a piece of code. Now, is it because we have delegates that can point to methods that we say, like, we can do away with methods at all? We can throw them out, we don't need them anymore. Well, not quite, right? Like, delegates are a way to basically pass methods around to other places of your code. Like saying tab.start, you need to have a delegate there to start something. It's not because you have that you say, like, C# doesn't have methods anymore, like we will do everything using delegates. Well, the same thing holds for events. Events are great, they're just a representation of something that can give you a message at some point in time. And if that thing is just sitting there and you're subscribing to it by just creating an event handler, that's totally fine. But if you do something more complex, or you want to pass that to a library, we provide a carrier pigeon for you to take up an event and pass it somewhere in. And that's called an iObservable, just like a delegate is a carrier pigeon for a method. Okay? So they're not obsolete at all. We wouldn't go in and start replacing all of the button-click event handlers in the world by using observables. Like, that's making console.writeLine into a delegate to call that thing to print something to the screen. If you don't transport those guys, you should not bother converting them to observables. So let's have a quick demo of events versus observables, just in Visual Studio here, and I will show you how to actually get started with classic, RX over here. So let me just go to C#. Why not? I'm in the WinForms mood today. So let me just do WinForms, a great source of a whole bunch of events. Like it's really the treasure, the treasury of events in the .NET framework, in my opinion. And here we go. We can just put a button here, and I'm totally fine with you still double-clicking on a button and creating an event handler. Like you're not going to hurt my feelings if you do that. So that's totally fine. Now, at which point does it become more interesting to start doing things using RX, using observables? Well, the answer there is, if inside this button you start doing a whole bunch of event processing based on that, like a whole bunch of logic that deals with the payload that you got from the button click, and as you know, the button click doesn't really have a meaningful payload, but as soon as you start processing that payload in some way, like filtering it and projecting it and so forth, at that point you need to make this mental switch saying like, oh, here maybe I should start using RX, okay? So let me do another example. Here you're hurting my feelings. Typically, if you go here and you say, let me try to write something, for mouse moves on this form, and in here I'll start doing things like, oh, if the coordinate of x is the same as the coordinate of y, then over here I want to delay the event with, awaiting a thread.sleep or task.wait or something, or task.delay, and all sorts of things. Like as soon as you start doing that, well, you should start thinking twice, because before you start starting up a timer here, do something else, whatever, and your resource management, well, the wheels come off quite quickly. So how do we make this a better place? I'm not going to come up with a complete example here. I have some in the slides. But just to show you the basic principles. The first thing you do is you right-click, add a service reference, and you go to NuGet. And over here you type RX and whatever the technology is you're using. RxXAML for WPF, RxWinRT for Windows RT applications, RxWinForms for WinForms, and if you're not doing any of that, just RxMain, which is the main library. This one will install a whole bunch of things. It will install main interfaces, core, link, platform services, and WinForms. So a whole bunch of little dependencies there. The reason for that is that all of the core assemblies in RX are portable libraries. It's only the platform specifics that we sort of want to have in separate assemblies, of course. So it's pretty big as a core in terms of common functionality, and then we have an additional set of assemblies like Windows Forms and platform services that provide platform specifics. Like if you're doing this on .NET 4.0, you will have different platform services than on 4.5.1, for example. So with this, I can now go somewhere, and I don't know where I want to go. Let's say I just go to the button here, and I want to do this conversion of the mouse move event into an observable sequence, because then I can start writing all those fancy queries on top of it. And we'll talk about the query operators in a moment. Now, in the world of delegates, if you have a private void foo over here, and you want to make an action carrier pigeon out of your foo, you can just do this kind of thing, which is called a method group conversion in the C# programming language. That's exactly the same as doing new action pointing to foo over here. Now C# doesn't know about event group conversions or something to observables. So we need to have a little helper method to make this work. So what do we do to actually capture the mouse move event from Windows Forms? Well, there's a bunch of overloads that you can use, but the starting point is the observable class. When I press Ctrl-dot, you will see it lives in system reactive link. And over there, you can do something called from event pattern to actually import the .NET event. Now, what's from event and from event pattern? Quite simple. From event pattern is those things with object sender event argc. Okay? Like that pair of things, which is just a convention. From event deals with any kind of event that you can imagine. Whether it's an event of type action or funcOfInt, yes, you can create events of type funcOfInt, and it's meaningless to do so, but if you want to do that, you can actually hook them up using from event. I'm going to use from event pattern, and I know that my event returns mouse event args. So I just pass in the event args, And then I have 6 overloads here. I could pass in a pair of delegates, one that asks me, when a user subscribes, how do I subscribe to the underlying event? When a user unsubscribes, how do I unsubscribe from it? Let me take this one. So as you can see, you see an event handler being passed in, event handler of mouse event types. All you have to do is take in that event handler and then go to the form, do mouse move, this.mouse move, and then plus equals h. So basically adding that event handler to it. And then that's the thing that will run when you subscribe to the event. And then over here you can also do the same thing to tell us how you want to unsubscribe from the event. And the thing that Rx will do, and actually those the events in Windows forms are not compatible with this one, this particular overload, so there's a little bit of a stink here. But the basic idea is just like when we subscribe, we need to know how we have to hook up the observer that's given to us to the event. And conversely, when you dispose a subscription, we need to know how to take it away. Now, what's the problem here? This thing returns or gives us an event handler of mouse event args, which is an event handler of T. Windows Forms was created in .NET 1.0, uses just event handler without T of T. Those things are not compatible for various reasons. So I'll just go for a separate overload here. You can actually make this work by passing in some additional generic parameters here, but at that point, we're sort of going off the screen here. So what I will do is I will just pass in, using the reflection overload here, I'll just pass in that I want to subscribe to this.mousemove. Not the best experience here, but one thing that I suggest you actually do, now that you've seen that you can use Roslyn, is just create a little code diagnostic that when you click on an event that it says, generate me the boilerplate code to make it into an observable. Really simple to do. Believe me, you can just see, oh, the cursor is on an event. I will generate some local variable that subscribes to it. Very good exercise to play with Roslyn, actually. So we just want to have this light bulb moment when you type over here this.mousemove, that a light bulb comes up on the left-hand side suggesting you, maybe you want to use Rx here. Let me do that for you, okay? So that's that. Now, what do I get back from this thing? Let me just call that MMS for mouse moves. A typical functional programming notation here to have an S if it's a sequence. So here I have my mouse moves. What's the type of that thing? Well, if you look at it, it's an iObservable of an event pattern of a mouse move event args or mouse event args. So I can subscribe to that guy like this, and now I can pass in an observer here. Now, I'm not going to pass in an observer. Instead, I'm actually going to pass in a callback. So as opposed to implementing iObserver and creating an implementation for on next, on error, and on completed, I can pass in a delegate, and we'll just create an observer out of it. So I'll just say, when I receive a mouse move, I want to do something here. And when we dot into the mouse move, we see we haven't lost anything. We have event args available, we have descender available. We're pretty much at square one compared to the mouse move event handler that I have at the bottom of the form here. Now, why bother if we're at square one? Well, the answer is, at this point, we can say, well, I don't want to know about this sender nonsense. I don't care about senders for events, for mouse move. Instead, I want to select the mouse moves from mouse move to mousemove.eventargs.location. And what this thing gives me here is an observable of points. So I'm projecting away all the crap I don't care about, and now I have a sequence of points. Now, you could totally refactor that thing into a helper to convert, an event into something that produces points. And then you forget about that, you've written it once and for all. You can just go here, right-click, and say, refactor, or where is that over here? Has that changed? Maybe that's changed. Oh yeah, extract method, yeah, exactly. And we call this method over here, get points for mouse, or something like that. And you can see now we're sort of partying on this, capability of having first-class event representations, because we can now have observables passed in, observables returned, something we could never do with .NET events. Now, of course, I can do much more here, and that's where things get interesting. I could say I want to have the mouse moves where the point.x equals the point.y, and then I want to subscribe when those points are changing. Oops, and that's a press of F1 as opposed to escape. So you see, now we can start flowing things by projecting, by doing where, a whole bunch of other things. What about, just annoying the user by delaying the delivery of the events with, time span from seconds, 1 second. So you're moving the mouse, but things will only move in the form 1 second later. If we're over the x and y coordinate, that's the same. Like, doesn't really make sense in this case, but you can see how you can start composing. And in fact, when you dot into an observable, what you are seeing here is a list of about, I've lost count, like 50, 60, 70 query operators that you can apply to those things. Maybe you want to average the location of your mouse position in windows of 1 second, like, to smoothen out the mouse moves a little bit. Like a whole bunch of things you can do here. I could say window them based on time spans of 1 second, do aggregates and all that kind of stuff. So a very powerful paradigm that should look very familiar to people who've used link to objects, but now on event streams. So let's go back to the slides and continue our exploration of the query operators, because the way to really think about this is maybe in terms of implementation, the bottom is quite hard and complex and there's a lot of stuff there. But in terms of use, you should think of this as an upside down pyramid, right? Like the value is on the top and that thing is growing all the time. Like some people created parser combinators over events. There's a project called RxX, Reactive Extensions, that basically builds query operators that you give a grammar. And you say, I have an observable of characters. That thing is going to parse and spit out things like objects that it has recognized, like credit card numbers in a stream of characters. That's stuff you can do. You can build things that take an observable of string and out comes an observable of matches, for example. Quite complex operator to write, but you can see how the streaming makes a lot of sense. So let's start with the hello world, and this is an example that you may have seen many times for those of you who are familiar with Rx, but it continues to be a very good example of the power of Rx. That's the dictionary suggest example. So what we want to do is, when a user types something in a text box, we want to set up some orchestration of a lot of things happening to basically turn that stream of text changed events into a stream of dictionary suggestions that's coming from a web service. Now, this is something you can do with async and await and all of that stuff as well, if you want to write event handlers and start awaiting web requests over there. And that works quite well to the point that you have to cancel stuff. Like the user typed something and you do backspace and you need to cancel the current thing. Well, at that point you need a cancellation token source or all that kind of stuff, and you need to be very careful about like how you cancel those things. So in some of those scenarios, it makes sense to actually go for an Rx approach. So what we really want to do is have an observable of text from a text box and then compose that with dictionary lookups on a web service. And if we think about a web service, really what it is, it's a function that given a word gives me a list of dictionary words, okay? So now you have two things. You have like a source of strings and you have then a function that can take a string into a source of dictionary words. So how can we compose those two things to actually make a very simple UI application? Well, the answer is like this. As you've already seen, we can use things like from event pattern to convert the .NET event into an observable. And here it's even more valuable to do that, because when text has changed in a text box, how many times do you go and cast the sender to a text box and get the text out? Because like when the text changed, typically you want to know about the text. Well, in Rx, no sweat. You can simply do from event in the text box, select the text that the user has typed. So you can project it out. Now, on top of that, you can sort of party with a lot of interesting things. If the user types the same thing twice, you don't want to go to the web service twice. So there's operators like distinct until change that filter out duplicates. You have things like throttle. If the user is typing really fast, you don't want to sort of denial of service attack your web service. You sort of want to wait till the user has calmed down for half a second, not touching the keyboard, and then the event can go through. That's a throttle operator. Do that manually? Well, you can do it manually with like a timer here, an event handler there, a cancellation thing here, and blah, blah, blah. Like, your application sort of explodes with a whole bunch of resource management stuff. Especially if you then close the form, you need to cancel your timers as well, of course. So a whole bunch of things that you have to take care of. Here it's just .throttle, .distinct, and so on. You just keep dotting things onto it. Now, the next thing you do is you want to compose that with your search Wikipedia function. Now, there's many ways of doing that, but here I have Search Wikipedia, which is just using asynchronous methods in C# 5.0. It's something that will do an asynchronous request to a web service and return a string array or something wrapped in a task. So that thing can use web client, all you wish for. And now how do we compose those two things together? How do we glue the two things together? Well, the answer is we can do something like this. We can say for every input in the text box that's been throttled and that's been made sure that it's not the same as the previous input that the user already had, we are going to project that onto a request for Search Wikipedia. So an observable of string gets projected onto an observable of task of string array, effectively. Now, one thing we can do here is we can make it even more RxY. We can actually turn it into an observable. We can convert the task into an observable. Now think about it, that makes a lot of sense because a task is a special case of an observable, right? An observable is something you subscribe to it and you get 0 events, 1 event, 2, 3, 4, n events. A task is something you subscribe to using continue with or await, and what do you get back? 1 or 0 results, whether it's a task or a task of T. That's a special case of the other one, right? Like it just makes sense that everything that's of arity1 is a subcase of the general case. So we can convert Wikipedia here to an observable, and then we can use an operator called switch. What's switch do? Well, we're projecting inputs here onto other observables. So what's the type of that, the first two lines here? It's an observable of observables. It's like a task of task. Now, how do you get the results out that are in that inner observable sequence? Well, with switch, you can do that. What does switch do? It listens for sequences. A new sequence arrives with inputs from or results from the web service, and it will basically feed those results onto the receiver. Until a new sequence comes, and that sequence says, like, I'm the newer sequence, you need to cancel listening to the previous one and switch over to the new one. So we're basically unsubscribing from the previous one, canceling, and then we're going to the next one. Can you do that manually? Sure, you can do that manually with a cancellation token source here, a cancel method there, newing up a new cancellation token source, starting a new request, all of that kind of coordination with a whole bunch of fields that nobody will understand what they're used for, right? Like, especially if you turn on StyleCop, which is not my best friend, and it says, like, you have to put all your fields on the top. And then you have like 20 fields there with different cancellation tokens for different methods and so forth. Your logic is sort of completely dispersed. Here you simply say, you know what, project all the terms onto Wikipedia results and then switch to the latest result you have. So like if the user types again, you want to cancel the previous one and switch to the latest one. And then finally, you do this, observe on dispatcher. That's just to make sure that you can access the UI framework. There's also observe on Windows form there, and then you simply do a subscribe to update, for example, a text box. So that's an example of how to bridge with .NET events using from event pattern, and how to sort of easily bleed into the world of task and async and await by converting a task to an observable as well. So a little demo. In fact, I will show you exactly this example using JavaScript this time. So I have JavaScript here. I have the repository from GitHub that contains all the examples of Rx for JavaScript. And we have an example here called autocomplete. And this autocomplete example is something where you can simply type to go to Wikipedia, and you see like it's kind of working. But when I pause, you know, that's the time that the request comes out. I can do 2 backspaces here. And it didn't search for React-T, it searched only for React, because like I was typing, you know, for a while, and we didn't want to go to the web service many times. So that's the throttle operator at work. I can also not type R here to download the whole dictionary, because the web service doesn't allow me to do that. So there's a where clause in here as well, saying only go to the web service if the number of characters is at least 3 or 2 or whatever the number is. I don't remember that. So let's take a look at how that's built by just going to the source. And actually, oh, that doesn't work. Go into the source here. Let me just open this one with VS 2030. So here you can see pretty much what I had in the slides just a moment ago, but now using Rx for JavaScript. And all the methods are the same. You know, they all look and feel the same. We in fact have TypeScript declaration files as well. I'm not using them in this project, but you could do this in TypeScript and get all the IntelliSense you wish for and all the compiler checking of all those methods. But you can see We do observable from event, same thing as from event pattern. In this case, getting the key up event of a text box. We're projecting with map, which is the same as select in C#. We're projecting that onto the value of the text box. So we have an observable of string. We only want to go through if the number of characters is larger than 2, because otherwise the web service complains that we can't download the whole dictionary. We want to wait for at least 750 milliseconds for the user to calm down. So if you're typing your word, that we're not going to the web service all the time. And we want to make sure that we're not re-retrieving the same thing as the user already asked for the previous time. Like if I type react, I do backspace and type T again, then it would be the same request going to the server. Like, we don't want to do that. And then there's a bunch of little things here. Flat map is the same thing as select many. Here we're doing exactly the same as what we saw just a moment ago in C# using select and switch. This is actually a combination of select and switch, flat map latest. That's just a macro, for convenience, because a lot of people are using this. And that one actually projects the inputs from the text box onto Wikipedia results and then switches to the latest result all the time. So you're basically switching the streams as the user types. And then finally, there's a subscribe over here that just does some HTML voodoo in order to render this thing onto the screen. So you can see the logic is quite condensed. If you have to do all that throttling and all of that timer stuff manually, your code would be all over the place, okay? In fact, if you want this thing to stop, the only thing you have to do here is hold on to this subscription object you get out of subscribe, which is an iDisposable. And to stop all of that stuff, at some point you could simply do not disposable, subscription.dispose over here. And then, it would be cancelled out. All the timers that still are pending are gone. We will try to cancel outstanding AJAX requests and all of that stuff. So very simple, simple set of primitives to work with. Again, the number of query operators is really big. So it's really like a chemistry kit. You can make anything out of it as soon as you understand the ingredients and all the atoms that you can smash together. So, and that's generally the case for query languages, of course. It's like, well, you're sitting in SQL and, oh my God, I didn't know there's also that keyword for that particular thing. Obviously, you need to know what's in there to use it, but just stabbing around, just spending the weekend trying all the operators is the best way to do that. Or some other day of the week. So with that, let's go to a second diagram and then switch gears a little bit and talk about some of the advanced stuff. So what does the landscape of async programming look like now with this addition of observable? Well, I've already alluded at a bunch of things that this world is super symmetric, and I'm really obsessed about, the symmetry diagrams where if you have 4 quadrants and one quadrant isn't filled up with something, something should be missing, right? So I'm going to fill in the 4th quadrant for anything I see as being incomplete. So we have synchronous functions. That's just func of t. We know that. We call a function, we get a value of type t back. It's synchronous, it's blocking. If the function takes a nap, then you're stuck there for quite a while. We have multiple values coming back in a synchronous fashion as well. That's called IEnumerable of t. So where func of t returns 1t, IEnumerable of t returns multiple t's. Every time you call move next and get the value, you get the next value. Now that's the place where you can write queries using link to objects. That composes over enumerable of t. It's just a library with a bunch of extension methods. Now in the asynchronous space, we have task of t. So you can just await something, and it's doing exactly the same as func of t, but just asynchronously. You await an asynchronous operation, a task of t, and out comes a t. It's a way to receive 1t, or an exception, just like a func can also throw an exception. Now, obviously, there needs to be a 4th thing, and that's IObservable. IObservable is about multiple events of type t received asynchronously. And it looks exactly like the enumerable world, where you enumerate over a set of results. Here you're subscribing to a set of results that may arrive sometime in the future, but you don't want to be stuck. You don't want to wait on the subscribe call till you receive events. You can move on with your life after doing the subscribe call. So it's asynchronous, as opposed to for each, which is synchronous, and the whole sequence needs to be drained before you can move on with your life. So that's really what the landscape looks like with IObservable. So all of these have a place, and there's conversions back and forth between all of these, actually. Of course, when you go from task to observable, that's fine. If you go from observable to task, you have to lose some messages, right? Like you have to pick which one becomes the result of the task. Just like you can make an enumerable into a func of t by using operators like first and last, which take a sequence into a single value. Now, because we have this sort of symmetry here, we can make things a little bit better together as well. For example, if you use classic async and await in C#, things are quite good actually. I love async and await for many things, but in some cases it can turn out to be quite imperative, okay? Like here's an example of timing out a task using task.whenAny. In my previous talk I actually showed you how to use task combinators to achieve this result. You just await for either the download to complete or a timeout to happen, and if a timeout happens then you throw an exception. Now this is very imperative and looks a little bit like wait for multiple objects in the Windows API. You're waiting for two things and based on what comes out, you throw an exception. Now wouldn't it be nice if I could just do something like .timeout on a task? And in fact you could write a timeout operator on task by just creating an extension method that does exactly that. Now you don't even have to write that extension method if you convert to observables. So here's an example of how we can do that. We have the web client. And as opposed to just trying to await the download string task async, I'm converting it to an observable. And then on observable, guess what? We have an operator called timeout. And timeout will, on error, a timeout exception to its receiver in case a timeout elapses before a message is received. Now, how do you then await that? The answer is, well, await is extensible. As we've seen in the previous session, you can build awaiters for anything. We built an awaiter for observable. So you can await an observable sequence as well. What does that mean? Because await returns a single value. Awaiting an observable means you will receive the last value that the sequence produced before an uncompleted happened. Why the last one? If you can get the last one, you can get everything. Why is that? If you want to get all of the values, you can always compose in operators like toList and toArray and those kind of things, which are aggregation operators. So it's always possible to get all the values as well by just getting a general way of getting the last one. So that's using the await over there. Let me actually skip over awaiting observable sequences. It's kind of peanut butter or peanuts, you know, to do that. So let's talk instead very briefly about Rx for JavaScript and then talk about how we're powering Cortana using the reactive extensions abstractions. Actually, I have two more things to talk about before we get there. So first, Rx for JavaScript. Now, in JavaScript, we don't have the luxury of async and await. So observables are even more useful to deal with classic asynchronous programming cases of single values. In .NET, there is one king for single value asynchrony. It's called task of t and async and await. And that's by far the best abstraction to do single value things. Just like you wouldn't say to add 1 and 2 together, you have to use arrays. That would be the same thing as us saying, you know, for single value asynchronous operations, you have to use observable, which are kind of asynchronous arrays if you think about it. So we're not doing that, but in JavaScript, you know, everyone is doing a whole bunch of callbacks, you know, promises and you know, name it, like a whole bunch of things that take in callbacks. So if you look at all those frameworks, they have different ways of dealing with callbacks. In this case, promise has a then function that you have to pass in callbacks, and it starts looking quite a bit like on next and on error here already, like, you know, a success callback and error callback. So a whole slew of places where you actually have to deal with you know, callbacks, but at the same time you don't get any opportunity to build query operators. While it may make sense to actually just filter like DOM events using a where clause or listen to, for example, WinJS events and filter them as well, you can't do that with all those different abstractions. So we can actually unify that and then provide composition. Now, guess what? It's the same thing, right? Like you've already seen before in JavaScript that you can actually go to a DOM event and do rx.observable.from event to subscribe to a DOM event. And really what's happening there is we're cleaning up this mess. Like, you know, the mess that you typically have in callback-based programming is to make things asynchronous, you need callbacks. And if you have callbacks, you have to restructure your code such that, like, everything flows correctly from one callback into the next one. So it doesn't look at all like imperative code anymore. It's a very hairy mess. And secondly, you end up with this resource management problem as well, just like with regular .NET events, that you have to symmetrically add and remove listeners by passing in the same handler object. So this is really a place where RX helps a lot to clean up that mess. So here's a more advanced example of using RX to actually do some stock analysis. Now this is really called complex event processing, because we're not just like listening for mouse moves and painting something onto the screen. Here I really want to get some business intelligence out of a stream of stock trade informations. So I have my stream called ticks, and what I want to do is I want to have an event stream come out of this that tells me when a stock for a certain company is up by at least 10%, let's say. Now the way to do that is by starting to group this stock stream, and you can do exactly the same in .NET by just using a capital G and a fat arrow as opposed to the function keyword. It's exactly the same API, but I'm going to tease apart those stocks based on symbols, because otherwise I can't compare the previous stock quote to the next stock quote in a given stream for a company. So I'm going to use group by to produce me a sequence of sequences. Now if you think about that, that's the same thing as in enumerable, right? If you do group by, you get an enumerable of I groupings, and groupings are I enumerables of T. So it's an I enumerable of an I enumerable. In the world of observable, you get an I observable of an I grouped observable, which itself is an I observable. So it's a stream of streams. What's the vertical stream or the outer stream? That's basically telling me, each time you have a new company that starts trading, you will actually get a new stream, MSFT and Intel Corporation in this case. Those individual streams, of course, contain the values for the respective companies. Now, next, what do you want to do? You want to project those guys onto the result of buffering the values on a per stream basis in groups of 2 with skip count 1. What does that mean? You want to get the first 2 values combined, and I think my slides are on automatic at this point, but you want to combine the first 2 slides, the first 2 values, and then compute something on it. Then you want to have the second and the third value, the third and the fourth and the fifth. That's what buffer does, okay? It groups them in pairs of 2. Now, let me skip back a little bit. Once you have those buffers, what do you do then? High school mathematics, right? You go into the buffers, you get the second value, subtract the first one, and you divide. So you basically get the percentage of change, positive or negative. Next, you do the where, to filter out those guys where the percentage is less, or filter out the ones where the percentage is less than 10%. So only select the ones larger than 10%, and then out of that, you basically get the company together with the increase. The only thing here is like with LINQ, this is very natural to write because you can still get access to your company as the key of the group. In JavaScript, you need to do a little bit more threading to this entire query to also flow the name of the company here. It's not hard at all, but it just doesn't fit my slide on the right-hand side. Like, it sort of runs off the screen there. But at the end of the day, you've gone from one stream of like unstructured data, a whole bunch of mess, into a stream that just tells me at the point in time where we know there's an increase of more than 10% that a certain company is indeed trading very well or very badly. In this case, I'm not using absolute values, so it's really very, very well. In fact, like my slide just has updated here to show you how you flow the key into this as well. And it actually fits because this is widescreen. Okay, that's quite good. So let me just show you one more example in RX for JavaScript. Like this one, we have it online. This example is called a stock trading example, but let me just go for some other example here. Let me show you, which one should I show? Canvas Paint, for example. That's a good one. So Canvas Paint is actually a very small JavaScript app where you can paint stuff. And, well, painting, you may say, like, that doesn't look too hard to do. Well, that would be the case if you actually had good mouse events in HTML or even Windows Forms or whatever. It turns out that in this case we just have mouse move events, mouse up and mouse downs to sort of get, whether the mouse button has been pressed or not. So we have to compose all of those different event streams to basically create a stream of events when the mouse is down and the mouse is moving. So we need to sort of do some complex event processing on mouse downs and mouse ups and mouse moves. And that can be done quite naturally using Rx. So let me go and just show you the Canvas Paint app over here, once more in Visual Studio here. As you can see, I have mouse move, I have mouse down, and I have mouse up. And how do you get the differences between mouse moves? Like the deltas of how much your mouse has moved between consecutive mouse move events? Well, the answer is you can do something like this. You can zip the mouse moves together with the same mouse moves, but sort of skipping one element. Like, a stream, you can skip one element, then you have like the current value and the next value, the current and the next, the current and the next. What do you do with zip? You pairwise combine those. The stream that's one element delayed and the stream that's just having the raw elements. Now you have something of previous and next, previous and next, previous and next. What can you do to get the deltas? You simply call a subtract over there. So that's what we're doing here. We're just getting the offset of the first and the offset of the second, and then later you will see some subtraction here to actually move the lines. Now we only want to listen to those mouse moves when the mouse is down. How do we know when the mouse is down? Well, we need to have a mouse down event, and while the mouse is down, we need to get those mouse moves until the mouse goes up. How do you do that? Well, you start by saying, I want to listen to mouse downs. And when the mouse is down, I want to listen over here. Well, actually, we're mapping both of them together. That's actually, yeah, okay, we do it slightly differently here. We basically turn mouse ups and mouse downs into a single stream. A stream of booleans that say, is the mouse down right now or is it not down? So that will be something that says true, false, and so on. Like when your mouse goes down, it's true. When your mouse goes up, it's false. So we're just merging those two streams and projecting downs into trues and ups into falses. And now over here, we can use again this combination of select and switch that we've looked at before, called flat map latest. In C# you could just use select and switch here to combine the mouse buttons here with to actually have the mouse buttons here and start returning the diffs or empty values, meaning the diffs will come out when the boolean is true, and otherwise nothing will come out. We'll just start returning zeros. Okay, so we basically get a stream of like when the mouse is down, we get like deltas. When the mouse goes up, we start returning over here an empty sequence. Mouse diffs.take 0 means like don't listen to that thing. So we switch from having deltas to not having deltas. And then finally over here we can simply compute the deltas, or in this case, with the canvas and HTML5, you don't really need to do anything fancy to compute, the two offsets and so forth. You can just move the cursor to a position and then have a line to a certain position and put a stroke on it. So to do that manually, you can do that, obviously, like you can do everything manually, but what you end up with is a whole bunch of state that's sort of ambient across all of those event handlers. And at the end of the day, you still can't get rid of this thing. Like if you want to get rid of this thing at some point here, you simply do d.dispose at some point on the subscription. And we take away all the event handlers and all of the state that's associated with it. If you have like 3 different DOM event handlers and a bunch of state and you want to cancel all of that stuff, you better don't forget to unhook any of them, right? Because then the whole thing blows up. So quite easy to compose once you sort of know this basic chemistry kit of query operators and start thinking in terms of data streams. Like, one stream, it's not the right one, let me project the bad things out. I have 2 streams, I want to merge them, let's merge them together. Just go into that flow of thinking in terms of sequences. And what really helps there is to draw those kind of marble diagrams to visualize. Like you start recognizing patterns. Like, if you want to split stock symbols, you want something to group them. You see 2 different lines, you think about a grouping operator, and so on. Let's actually skip mostly over the scheduler. That's sort of the execution engine at the bottom of Rx. I'm just going to sort of race through that really quickly because in practice you don't really have to see them all that often. What schedulers really give us is an abstraction over where we execute code. Like in Rx, if you do something like throttle, you could say, well, throttle needs to run a timer. Where does that timer come from? And in the .NET framework, you have like 5 different ways of creating timers: a Windows Forms timer, a task.delay, a system threading timer. Like, you should be able to parameterize which one you want. And that's where schedulers come in. So when you go to things like timer, you can pass in a scheduler. In JavaScript, we have that too, because you have things like web workers that can do things. You have things like the DOM timers and all of that stuff with set timeout. We can actually abstract over those different ways of introducing concurrency. So here's an example. Say that I do observable return, which gives me a sequence that just has one element in it, and I want that element to be produced with an onNext call on the thread pool. Then you end up in this particular situation in Windows Forms because you can't update the UI from a background thread. So the way to fix that is by actually using schedulers as well. And we've actually seen a case a little bit before in Dictionary Suggest where I was just using observe on dispatcher. Like, just think of observe on dispatcher as a shorthand for doing this.invoke or this.begin invoke to switch to the right thread. You can just compose that thing in, and typically in UI applications, you will always see this observe on straight before your subscribe call in your UI. So there's also some shorthand for that to make it as friction-free as possible. Now, the reason for not doing everything on the UI is that you don't want to have all that background processing happening on the UI, because then you're starving UI processing. So it makes a lot of sense to do all of the heavy compute and all of the event processing of the UI thread, and then at the last point in time, when you have to render something, use observe on to switch to the UI thread. The scheduler interface, I'm just going to skip that one. And how the query operators sit on top of the schedulers, I'm going to skip that one as well. That's just an interesting read and some curiosum on how the disposable that you get back from a subscription has a deep effect of being able to cancel work all the way down in the scheduler. So the cancellation is not something vague or undefined. It's actually going quite deep into the scheduler layer to take away all the work that you didn't care about. Now, the one place where schedulers are actually very useful, besides being a curiosum, is that you can write virtual time tests using them. Like, as we've seen before, we have this mouse move thing just a moment ago, and yeah, you know, once you know what the code does, it's kind of logical to sort of think about it, but you may want to test that thing. But do you want to sit there like a crazy monkey sort of moving the mouse all the time? Like, not really, right? Or if you're testing some query that uses GPS coordinates to find when you're near a grocery, do you want to test your app by walking to the grocery? Like, chances are that the police will come if you're there 5 times a day not going in, right? Like, you know, what's that guy doing in front of the grocery all the time? I'm testing my Windows Phone app. Like, that may not fly. So instead what you want to be able to do is like fake a sequence of GPS coordinates. Like, you go and walk once in front of the grocery store and you get like all the GPS coordinates of your path, and then you want to record them and sort of replay them in virtual time. Because maybe your query says, notify me when I'm in front of the grocery during opening hours. Well, then you can't test your app at night. Like, so you want to virtualize the time sequence, you want to virtualize the events. So with schedulers, you can do that. You can say, create me a sequence in virtual time where at time 300 something happens, at time 400 something happens, at time 500 something happens. And you could make those things based on ticks from real datetime offsets, of course. Like, it's just a long value. It's just something that needs to be that needs to have an order in it. Now, on top of that, you can write your query. In this case, a simple one, but in the case of mouse moves, you may have something complex, right? You may have all of that stuff with, you know, flat map list and all of that stuff, or flat map latest. A whole bunch of things that you can put in there. So this could be like 2 pages of an RX query sitting in there, and then what comes out is some results. And you just assert in virtual time that at the right time, the right value comes out. Like, when I move my mouse, when there was a mouse down at time 200, and I moved my mouse at time 300 from position 5 to position 10, and the mouse up happened at time 400, then at time 300, I want to have a delta of 10 come out. But not when the mouse moves outside at the time where my mouse is down. So you can simply assert using the unit test framework in .NET, and we also have something in JavaScript there, that things in virtual time indeed happen at the right point in time and produce the right results. So let me actually skip over that one as well. We have very good blog posts about how to do that. It's actually quite a long one on the RX team blog. What I want to talk about, though, in the last 10 minutes is the stuff I've been working on for the last year and a half, almost 2 years actually, bringing RX to the cloud to power things like Cortana. There is this funny type that we have in RX called IKEobservable. And I don't have a speech deficiency, well, not for this one at least. It's the right pronunciation. It's IObservable spelled with a Q. And I'll show you the interface in just a moment. But that's actually the one that powers Cortana. So what we're talking about here is expression trees. Somebody in the cloud says, notify me when I'm near a grocery store. Like, we need to send that thing to the cloud and to the device. We need to go onto the device to execute an RX query. How do we do that? Well, we're not going to download the binary that contains that RX query or something. We want to submit an expression tree that describes what the user wants. Similarly, if we have to park something in the cloud, we want to do the same thing. We want to transfer an expression tree to the cloud where we can actually execute it. So in Link, we already have that. We have the capability called iQueryable, where you simply write an RX query, well, not an RX query, a Link query, and you can send it to, for example, a SQL database by translating it to T-SQL syntax. And that's called iQueryable of T. Now, in the world of observable, you can do that as well. You can have queryable or expression tree-based representations of RX queries that get executed by something other than the CLR in the local process. For example, you can build Link to WMI events, and in fact, that example is online, so you can actually play with that. Meaning you start writing a query that says, notify me when a certain process with a certain executable name starts. So you can just do that. And you won't get all the process start events into your local process. Instead, what you will send to WMI is the filter condition, and that one will take care of it. Similarly, you can do Link to PowerShell, Link to Twitter, like, sort of listen for tweets containing Lady Gaga without getting the whole Twitter fire hose onto your machine. You want Twitter to filter that out. Now, Cortana actually speaks expression trees, both on the device and in the cloud. And it uses exactly those abstractions that we've built for RX a couple of years ago, called IKEobservable. Now, IKEobservable is not a typo. It's just a little pun on something theoretical called homoiconicity, meaning that things that look the same have the same syntax, and you don't have to worry about implementation details. So whether you have an observable or a IKEobservable, you write exactly the same code. You write where clauses, selects, just everything you want on top of that, but the machinery that makes it work is fundamentally different. In one case, it's the CLR that does everything, the observable case. In the other case, God knows who's doing it. You just get an expression representing what the user wants, and some system executes it. So that's the IKEobservable interface. Now with that, that's my last diagram, I promise. We have this supersymmetric world of enumerables that do local pool-based enumerable style execution using iterators. We have observables that do local push style evaluations of event processing problems using the RX query library. We have iQueryable to represent Link queries as expression trees and execute them, for example, in SQL. And we have IKEobservable to have an expression tree representation of an event processing problem and have it execute, for example, by WMI or the Cortana service in the cloud or on the device. So let me actually briefly try to remote into my box in Redmond here. Here we go. And this is actually the core engine that we've built. In fact, I'm leading a team called IRP Core, and IRP stands for iReactive Processing. So that's actually the foundation of event processing both on the device and in the cloud for Cortana. And that's completely based on the RX paradigms. And here is actually the remoting solution. There are 69 projects in here. About half of them are tests, the other ones are real assemblies that get hosted inside the data center as well as on the device. So what I have here is the remoting stack. That's not the real stack. That's basically something that hosts our components using .NET remoting on the local machine. And that allows me to test, all of our bits, which have query optimizers, expression tree rewriters, a whole bunch of crazy things in it. Now, the key abstraction is very simple and something you will be immediately familiar with at some point in time when we open this up for more public use. The way to think about this context thing is an interface called iReactive that represents a remote system that can do event processing. Now that remote system can be a phone using RX for C++, it can be a cloud something, it can be one of the worker roles in our cloud, it can be an external service. Like we have some external services for traffic info which implement that same interface. And the way you interact with that is like Link to SQL. You go to it and you say, please, dear context, I know that in your cloud somewhere, in your almighty cloud, you have something that can give me weather infos. And the stream containing weather infos has a certain URI. That's not a physical location, that's a logical URI. So it could be something like Bing/feeds/weather or something. Okay? And at that point, you get a proxy to that stream. And once you have the proxy to the stream, you can start writing queries on that. So now I have access here. I can do access dot. And guess what? We have a subset of the RX operators here. We don't have all of them. Some of them are quite expensive to run in the cloud. Some of them, you don't want to run on the device. But so we can serve up all the ones that we support. So we can do things like compose this thing with a where class. Now, as you take a look at this, what you see is that context get observable returns something of type, not a typo, observable. It's actually a derivative of the RX work because we had to add some cloud concepts in here, but the fundamentals are exactly the same. It's an iasync reactive observable. Now, what does that thing do? It looks like it has a subscribe method, but it has a slight variation of subscribe that you're familiar with in RX. It has something called subscribe async. Why async? Because we're going to make a network hop to the cloud or to the device. That's what the async part is about. We want to know whether we were able to set up the subscription correctly, so we can await it to see whether it succeeds setting everything up in the cloud. You pass in there an observer, and this observer is not a regular observer, it's also a observer. That means it's an observer that runs in the cloud. Because my phone is not always connected to the Cortana cloud. We want to post an entire event processing problem into the cloud, and the observer may be something that uses Azure push notifications to try to deliver a message to the phone in a loosely connected world. So the observer is not local, it's also something we want to lift up to wherever the event processing system is running. And finally, I need to give this thing a URI to identify my subscription. That enables me to later come back and say, please give me my subscription object back, I want to dispose it. Because in the classic world of RX, if your process dies, you lose your iDisposable, and then you can't cancel your stuff anymore. So you need to give every resource a name that you can use to identify it. Now with that, we can write something very simple, and I don't have a weather feed in my remoting solution here, but like if I would target this context to the real Cortana cloud, I could tap into weather events and sports events and traffic information, and you have it. In this case, I'm just going to locally run a range observable, which just produces 0, 1, 2, 3, and 4. Like in this case, range going all the way to 5. And I want to subscribe to that a console observer, which will just do console write line. In reality, we have things like Azure push notification observers, HTTP observers, SMS observers, you name it, all that kind of stuff to deliver notifications to users. And I will give this thing a name over here using a URI. So if my application would die, I could do something like context get subscription, passing in that URI, and then call dispose async. It's not an iDisposable, it's an async disposable because we're making a hop to the cloud and we want to know that this thing indeed succeeds. But other than that, it's exactly the same thing as RX. You can come in here and start writing queries, a whole bunch of them. So let me just hit F5 here, or Control F5, and you will see over here a local variant of our cloud service being bootstrapped in one process that indeed is printing a bunch of numbers. The reason it takes a while is because I'm starting from scratch and I'm actually deploying all of the query operators into my system. Now I can make one change here to make my mock of the platform use TCP. Now it's using some real communication stacks here. When I hit F5 on this thing, when I'm talking with those observables and do subscribe async, I'm going to a different process here. So you see we've already started up 4 processes. The first one is some state store, or the client, some state store, a messaging connection, another storage layer, a query evaluator, which is a worker role, and a query coordinator. And what the query evaluator is, that's the one that's actually running a variant of Rx that supports checkpointing, so we can actually save the state of a computation when the machine goes down. And we're now waiting for the thing to be deployed. Here we go. And we see indeed that the query evaluator, that other process, is actually doing console output. That's because my observer is not the local observer for the console, but one that's running on that remote system somewhere in the cloud. In reality, it will not print to the console because we don't have our users living inside the data center. Instead, we will actually push notify them or do something else with them. So here you've gotten a very simple sampler of the kind of stuff we are building using reactive in the cloud and on the device. And you can see the abstractions are very easy to grasp. It's really just the same thing as LINQ to SQL. You get a table, you write a query, you enumerate. Here you get an observable, you write a query, you subscribe. Pretty much the same thing. Only difference is that you have to give things names so that we can identify them. You can also define things like stored procedures and stuff to sort of define templates of queries and all sorts of fancy stuff there as well. So, with that, I think I'm done, like we are uncompleted. The one takeaway I would like to give you is like start thinking in terms of events as streams of data and sort of transform your thinking. Like at some point, most likely you had to transform your thinking about how you do data programming with relational databases. The first time you look at something like SQL, you say, oh my God, this is declarative, I can't set a breakpoint in the middle, I don't know how my data comes out. That's the nature of those declarative systems. But once you know the grammar, once you know all of the operators that you can start gluing together, you know, all the power is to you. Like you can really express very complex problems with high resource usage and resource maintenance in a very compact way. And then you have a simple way to clean up resources, to compose on it, to refactor, to mock, and do all that kind of stuff that otherwise you wouldn't be able to do. So with that, I've come to the end. Please fill out evaluations. Let us know what you thought of the different talks we had here today. And I hope to see you again sometime in the future. It won't be at this conference anymore, but maybe next year or something. Thank you.